Welcome back, WAMers. We're on 5.1 triangles, and last day we worked on a handout with all of the different things you need to know in order to start doing these examples. So example 1 on page 182 is where we're going to start today. Here you're given 3 different shapes, and for this here would be shape that we're going to look at in point A here. So we want to find angle A, B, and C for this shape A. So what do you know about the triangle on the edge of this shape? So what do we know about this triangle? All side lengths are the same. So what do we call that? Equilateral. Good. So this is an equilateral triangle. So if you have an equilateral triangle, what does that mean for your angles? They're all the same. So what are your angles equal? 60. Good. So angle A equals angle B equals angle C equals 60 degrees. Okay, then we're going to look, would be called triangle B in part B, and we're trying to find angle A. Now this got cut off when I copied and pasted this. This here is a 67-degree angle. So we have a 90 here in the corner, a 67-degree angle. So how can we find angle A? So all of these angles have to add up to 180. So we go 180 degrees minus 90 minus 67, which will give us our answer for angle A, equals 23 degrees. And the last one, C. Here for part C. We're looking for angle B and angle C. What type of triangle do we have here? Isosceles. Good. And it actually tells us that this angle, again, that got cut off, this is a 50-degree angle. So what do you know about the 2 other angles in an isosceles triangle? They're equal. Good. So angle B and angle C are both the same. And all 3 angles have to add up to 180. So we're going to take 180, subtract 50, and divide that by 2 to get 65 degrees per each angle. So angle B and angle C both equal 65 degrees. Next, discuss the ideas. Triangles for a roof. So this guy owns a lumber store in BC. The store sells 2x4s in 6 feet, 8 feet, and 10 feet length. So those are your options. He wants to make a triangle roof that can be made with these lengths of lumber. We're going to start by figuring out this table, all the possible different options for the triangles that can be made. So he started here. He could have one side 10, another side 10, and the third side 10, which is making an equilateral triangle. Let's say that he wants side 1 to be 10. What's another option for side 2 and side 3? So he's got 8 foot, 10 foot, and 6 foot lengths. So he could have 8 foot. Good. So he could have a 10, an 8, and an 8. This would be 2 numbers of equal sides, and the type of triangle would be isosceles. We'll do one more together, and then you can figure out the rest on your own. One more triangle that you could make. 10, 6, and what? 8. Sure. So this, no sides are the same. So the type of triangle, this would be scalene. But we know from our Pythagorean triples that we've talked about, if we divide each of them by 2, we actually get 3, 4, 5, which is a right triangle. So this is scalene, but it could also be considered a right triangle. Okay, go ahead and fill out the rest of your chart. There's 10 total different possible triangles that can be made. So just double check your chart to make sure it looks like this. Okay, so then, we have to go back to our questions. If a customer wants to frame a roof for a shed that is 10 feet wide, which combinations will make a symmetrical roof? So let's look at our chart here. Which ones would work with a symmetrical roof with one side at least being 10? Okay, so that's option 2. Option 4. Perfect. Good. Those are your 3 options. So options 1, 2, and 4 would work. So options 1, 2, and 4. What are the interior angles of trusses that form an equilateral triangle? 60. Good. So whenever you have an equilateral triangle, all angles measure 60 degrees. Should write that down properly. All angles measure 60 degrees. Here we have, this sketch has a 10-foot base and two 8-foot sides. Write the sine ratios of angle B and angle C. Why are they the same? So to set up these sine ratios, if we're calling the height of the triangle here AD, then sine B equals AD over 8. Because here we have angle B, AD is opposite, 8 is the hypotenuse, so AD over 8. Same with C. Opposite here for angle C is AD, hypotenuse is 8. Now by our transitive property, that means if two things are equal, they're also equal to each other. So sine B equals sine C. If we get rid of the sines, we're left with angle B equals angle C. So this just tells us that whenever you have an isosceles triangle, your two bottom angles will be congruent. Okay, example 2, page 184. We have a surveyor who needs to measure the distance between 2 points A and point B. So here's point A, there's point B. However, there's a huge, what is that? A rock in the way? Sure, let's call it a rock. It's in the way, and she positions herself at points C, D, and E so that she can see both of these 2 points. Why is she not able to find the distance of AB by standing at point C or point E? Because they're not right angles, so why does that matter? Okay, so we need to know that because otherwise we wouldn't have enough information. So we would need to use the one there that has a right angle. For part B, she positions herself at point D. Distance AD is 15, and distance BD is 20. Good, so we have a right triangle, we need to find length of AB, so we're going to use Pythagorean theorem, which is a squared plus b squared equals c squared. So let's call A 15, B is 20, and C is our AD. This is our hypotenuse because it's across from the right angle. So when you figure that out, what do you get side length C or side length AB to equal? 25, good. So 25 meters. Next we have mental math. She made a right triangle with one side 3, one side 4, and the hypotenuse 5. Then she changed it. She said, oh, that's not big enough. So she made a bigger one with sides 6, 8, and 9. But now she's wondering, is this still a right triangle? Why or why not? Go ahead. So I just realized I probably didn't explain triples to the distance ed group. We did this last year in Workplace and Apprenticeship 20. So a Pythagorean triple are just right triangles where each side length is a whole, is exactly a whole number. So one example of a triple, and the most common one, is 3, 4, 5. Then what you can do to that triple is you can double all side lengths, triple all side lengths, and it's always still going to be a right triangle. So if you look to this mental math question, the number 9 is not one of our triples. This original triangle we have is a triple, and if we double each side length, we'd get 6, 8, and 10, not 9. So that's an easy way using mental math to figure out if it's a right triangle. So this answer is no, it's not a right triangle. Then you have an assignment on page 187, number 1 to 7 all. And if you have time, please try the toothpick challenge.